Hey everyone, in this video we're looking at how to compute the standard deviation or the variance of discrete random variables. I will expect that you already know how to compute the mean or the expected value, as this is part of this calculation. So we're looking at the example that we saw in the mean and expected value video. This random variable x is the number of men in a sample of size 5 that are colorblind. So x can take on any value 0, 1, 2, 3, 4, or 5, and we have a little table here with the probability of each of those outcomes. We calculated the mean or the expected value in the previous video, and that mean was 0.403. So on average, in a group of 5 men, the average number of men who are colorblind is about 0.4, so between 0 and 1. What we're looking at in this video is how much variation is there from that average. So is there a huge amount of variation in x or not very much? Now in this case, because we know x values can only go from 0 to 5, we know that the variation is fairly limited because the range is limited. But we can actually see that the variation is even smaller than we might have in a range from 0 to 5 by looking at kind of the average deviation from this mean. So each given outcome, 0, 1, 2, 3, 4, 5, how far away is that from the mean? And that difference from the mean is going to be weighted by the probability. So in some cases, this calculation is very similar to finding the standard deviation of just a data set, but we do have this probability to account for here. Here is the formula for the variance. So the variance, which we denote as sigma squared, this is the same thing as the standard deviation squared. That variance is going to look at this expression x minus mu. X minus mu is the difference between each x value and the mean. So that's the deviation in standard deviation. So that deviation squared, and then times the probability of that particular x value. So we have those deviations squared weighted by the probability, and then we add them up. That's what our sigma notation here is saying. So this is the variance. In most cases, we're not going to be using the variance directly. We're just going to calculate the standard deviation, which is just the square root of the variance. So standard deviation, which we denote as sigma, is this formula square root of, and inside the square root we have our sum, the Greek letter sigma, sum of x minus mu, or x minus the mean squared, times the probability of x. If you don't feel comfortable with the algebra in this formula, you could definitely just write this out in words or kind of take notes on the process as we compute this in Excel. So I'm switching over to Excel here. This is the probability distribution table. So I have my x values 0, 1, 2, 3, 4, 5, and the probability of each of those x values 0.659, 0.287, 0.05, 0.004, 0.001, and 0. And we already computed the mean in the last video, so that was the x times p of x for each value, and then we added those up to get the mean. I'm leaving this computation in here because the mean is part of the calculation of our standard deviation. So I'm going to take out the formula here, and I'm trying to compute this standard deviation formula. I'm going to approach this by kind of sorting through the order of operations. So in terms of order of operations, the very first thing we need to do in this formula is calculate x minus mu, or each possible x value minus the mean. I'm going to create a new table for this. At the top, I'm going to write x minus mean, since it's a little hard to type mu. And I'm going to do this as a formula. So equals, I'm going to click on the box where my x value is. The first x value I have is 0, minus. Now I want to click on the box that has the mean, but I can't just use that cell reference. My mean is in the cell D9, but yours might be somewhere else. But click on wherever you've computed the mean. But when I drag the formula down to compute this x minus mean for all the different x values, I don't want it to keep updating. I don't want it to drag down that reference for the mean. I only want it to do that for the x. So I'm going to lock the mean reference in as an absolute cell reference by adding dollar signs. So I have here $D, $9, or whatever your cell is. Add those dollar signs to lock that in so that when I compute this first value, I have that first x value 0 minus the mean, which gives me negative 0.403 in this case. And then I'm going to drag the formula down by clicking on the lower right-hand corner. And if I look at one of these formulas, you'll see that in this 6th row, it's taking A6 minus still D9. So it's not updating the mean, it's only updating the x value. Okay, so I have that x minus mu calculation for each value of x. The next step in order of operations is to square each of those differences. So I'm going to do this as a new column just right next to my x minus mean. I'm going to do x minus mean squared. Now the x minus mean portion I've already computed, so this next column I'm just going to be taking each one of these differences, the x minus means in the column next to it, and squaring it. So I'm clicking on that cell and doing squared, which is the caret or shift 6 and then 2, so raised to the 2nd power. So I'm going to compute each value squared. I'm going to do that first one as a formula and then drag it down so that it is computing each of these x minus mean values squared. If I check on one of these formulas in the 6th row, I have equals f6 squared. Now keep in mind that depending upon where you put things in your Excel spreadsheet, you might not have f6 squared, maybe you have e6 squared or whatever. Look for where your x minus mean calculations are. So that is each one of those differences squared. And then I need to take that times the p of x. So this is x minus mean squared times p of x. I'm just adding these as labels up at the top so I know what each of these values means. So equals, I'm going to take that x minus mean squared from, in my case, column G, times the probability, the p of x. Now when you go back to the original table, you want to click on that number that represents the probability of the x value. I often see people accidentally click on the x times p of x from the mean calculation, so just be aware of where you're clicking. We want that probability of x from the original table here. And just like the previous steps, we need to drag that formula down to fill in the table. All right, so that is the last step that is performed for each x value. The next step in my formula is to take those products of the x minus mean squared times p of x, take all of those numbers and add them up. So I'm going to use equals sum, parentheses, and then add up all the numbers from this column. And this number right here is representing the step in the formula corresponding to the sum. We have one last step in this formula, and that is to take a square root. So this number here is actually the variance. If you are trying to compute the variance, you could just stop here. But the standard deviation will just be that previous variance number with a square root. So I'm going to use equals. Square root in Excel is SQRT. So SQRT parentheses, and then I click on that number. My variance is in cell H9, and then pressing enter, I get my standard deviation. So that last step of the square root is giving me this standard deviation. In this case, I get 0.6138. So about 0.6 is my standard deviation. This is again saying that on average in a group of 5 we'll see about 0.4 men who are colorblind, and that varies by about 0.6. So that 0.6 is giving us a measure of how much variation we see typically in the x value. We know that in general we can see values anywhere from 0 to 5, but based on these probabilities, some of those larger numbers are pretty unlikely. So the average variation or the standard deviation is 0.6. I'll look at one more example here. The second example was from our mean and expected value video. X in this probability distribution represents the number of calls received in an hour at a customer service call center. So the average, or the mean, was just under 16. 15.93 was the mean from this probability distribution given in a table. But we want to know, what is the standard deviation? So how much does that number of calls vary? So if we're trying to staff, it would be good to know the average number of calls in each hour, but we also want to know how much spread there is. So here I have my probability distribution table in Excel. I have all the X values ranging from 10 to 22, and then the probabilities of each of those in column B. I've already computed the mean, and this involved calculating X times P of X for each of these values. I don't actually need this calculation in here, but I am going to need the mean. I'm actually going to move it to a different place in Excel so that I have it accessible, but it's out of the way. So I've got my calculation for the standard deviation, my formula here. I'm going to again work from the inside out, so starting with X minus mu, or each X value minus the mean. I'm going to create a column for this. I'm putting it in column F, but you can put it wherever you like. And I'm going to do a formula equals, I'm going to click on my first X value, which in this case is 10, minus the mean. My mean is in cell D16. And just like in the last calculation, I need to kind of lock that D16 in place. So I'm adding dollar signs by editing the formula bar up here towards the top of the window. So I have A2 minus $D $16. This way, after I calculate my formula, I can drag this down and it will automatically update so that each cell is looking at the next X value, or whatever X value we have for that row, but that the mean is not going to change. So it's always going to look in cell D16 for our mean value. So that's my X minus mean. Next step would be to take those values and square them. So I'm doing that in the next column, equals, take that X minus mean calculation and square it. Drag this down. And then I need to take each one of those, X minus mean squared, and multiply by the probability of X. So equals, take my X minus mean squared times probability of X coming from that original table for that first X value, and then again drag this formula down. Now I'm doing this here in 3 different steps. So I have the X minus mean, I have the X minus mean squared, and then the X minus mean squared times P of X. You actually could do this all in one column if you wanted to. So if you prefer, you could do equals parentheses the original X value minus the mean with the cell locked in place, and then end my parentheses. I'm going to square that result times, and then my P of X. So you'll see that in this case I'm doing one formula to do all those 3 steps at once. You'll get the same answers as if you had done it in 3 steps. This is just an alternative if you feel comfortable doing this all as one formula. You just need to be careful with the order of operations. But either way, whether you do that or just stick with the 3 columns here, we need each of those X values minus the mean squared times the P of X. The next step in our standard deviation calculation is to sum up all of those values. So underneath this column, I'm going to do equals sum, and then highlight all of those calculations. This number here would be my variance. And then the last step is to take the square root. So equals SQRT, parentheses, click on my variance, or that sum, and close the parentheses. You can also do those 2 in one step if you prefer. So maybe over here I do equals SQRT, parentheses, and then SUM. You can do the square root of the sum of these values all in one. It doesn't really matter as long as you're doing all the correct calculations, you'll get the same answer. So the standard deviation in this case is 2.55. Both the mean and the standard deviation, the units here would be calls. So on average, there's about 16 calls each hour, and that varies by about 2.5 calls. So that gives us a sense of what a typical number of calls will be. We know they range in general from 10 to 22, but the average number is 16 plus or minus about 2.5. So we can use the mean and the standard deviation to get a sense of what the distribution of our random variable is, just like we used those same calculations for a data set to get a sense of what's going on in the data. That's it for this video. Thank you for watching.